First off is a stem plot. So what a stem plot allows us to do is it allows us to summarize data rather quickly without using a histogram or a dot plot. So what it's going to do is it's going to group numbers by the tens digit, and then we're only going to list off the ones digit. So for example, for this 4, we're going to be looking at only numbers in the 40s. And then when we list off the numbers, we're only going to list off the ones. So 43, we'd record as a 3. 42 would be recorded as a 2. 42 would be recorded as another 2. And 40 would be a 0. So we're going to continue to do this. So 34 would be 4, 3, 2, 2, 2, 2, 1, 1, 0, 0, 0. And then 20s, we'd have 9, 8, 7, 6, 5, 5, 4, and 3. And then for the teens, we would have 2, 1, 1, 1, 1, and 5. Now the cool thing is that if you're working in the field and you don't have access to a histogram or anything digital like that, what you can do is that if you turn this sideways, so if you rotate it like this, you've seen that you have made a histogram, and you can see where the peak is, where the most popular values are, where the least popular values are. Very cool. We're not going to be using those too much, but it's still good to know. Now, when we talk about distributions, aka the shape of the graph that we're making, we're going to have a typical value, which we are going to call the center, the center or the peak of our data. We are going to be talking about the center or the peak of our data, and we're also going to be talking about the spread or the variability. This is going to get another name later on, but for now we're just going to call it that. So what we're going to be doing is comparing women's goals in soccer and men's goals in soccer in the year 2012. Now if we look, the peak on women's is between 12 and 15, as is the peaks on men. So the center for women is between 12 to 15, as is the center for men. However, if we look at both of these, we can see that they have very different information. So here we have a much larger spread than we do for men. So for the spread, one way that we can summarize the spread is to say that it goes between 9 to 36 for women, while the spread for men only goes between 6 to 21. Now, I would still say that men's and women's isn't that different, and the reason why is because we only have one observation here that's very far away from the other ones. So if we removed that observation that's kind of lying out from the other observations, maybe we would say instead that it's 9 to 24. By the way, an observation that's far away and doesn't have a whole lot of frequency is called an outlier. We'll talk about those a little bit later. Okay. So when we're talking about the shape of a histogram, there's 3 things that we want to know. Is it symmetric or skewed? How many mounds appear? And do we have any unusually small or large values present? So one example is, let's say that we have a graph that looks something like this, our histogram. Okay. So if we were to kind of drape a blanket over this, what we would see, and by the way, this x would be the average. Okay, this has one mound. So it has one mound, this guy. And when it has one mound, it is called unimodal. As well, since we could cut it in half, and we would have a nice symmetry, what we could do is we call this symmetric, which is also called normal, which we also call a bell shape. So what happens with this kind of distribution is that we have most things fall around the average, and then we have less on either side, and then less still on either side as we get further from the average. So for example, this could be heights or weights, anything where most people fall around the average and then kind of taper off. So for example, it's really common to see a woman who's about 5'6", but maybe not as common to see a woman who's 6'1". All right, now the next one is where we see maybe not many smaller observations, but then they get larger as time goes on. So something like this. Okay, so the average is actually still here, but the center is here, so that means that the peak is over here. So what this is called is it's actually called left skewed. The reason it's called left skewed is because the average is to the left of the center. It is also still called unimodal. Now, what this could be is this could be talking about the age of death. So hopefully most people die older, okay? Or it could also be the number of fingers somebody has. So most people have 10 fingers. Not many people have less than that, but you know, it does exist. Now, one silly thing that I do when I draw these is that I like to make a little monster. This is its like creepy little arm. Anyway, this is my mound monster. And whenever I think of a mound monster, I'm always like, okay, which side do you want to be on? The mouth side or the tail side? Well, you want to be on the tail side because you don't want to get eaten. So that's how you know it's left skewed. I know it's silly. I do like to draw monsters, so if you guys like to do that too, that's fine. Alright, now since we have left skewed, we're also going to have something called right skewed. So our center is here, while our average is being pulled up. So our average is to the right, so that's why it's called right skewed. And it would still be unimodal. Now, in this case, it would be where people tend to have more observations on the lower side, and maybe not so much on the upper side. So we could think of this as wage, age of vaccines, number of traffic tickets people have. Okay, so those would be some examples of right skewed data. Now, if we look at the following data, let's go ahead and identify where the center is in the skewedness. So the center is where we see a peak. So our center in this one would be 64. And if we want to talk about its skewness, well, this one looks like it's pretty well symmetric. So we'll say it's normal. So no skewness. All right, for this next one, let's say that's about 25. I would say the center or the peak is probably somewhere around here. So I would say somewhere between 20 to 25. And also if I draw a blanket over this guy, well, what I see is that the center is here, which means that these bigger values would pull my average up. So this would be right skewed. Also, don't forget, if you want to draw a monster, I always think he looks kind of nice. Like he's like, I'm not so bad. I kind of like math. See, we'll give him a smile. Okay, we want to be on the right side of the monster. So I know it's right skewed. Alright, for this one, the center, or the biggest peak, looks like it's between 80 to 90. And for its skewness, well, it's the opposite of that one, which was right, so this one would be left skewed. Nice. Now, the last two things we're going to talk about are when you have two modes or two centers like this. So in this case, what we're looking at is we're looking at the amount of customers on a given interval of time at a local Port Orchard Safeway. So because this has two mounds, what we would say is that it's bimodal. So bi means two. Now what happens when you have a bimodal or multimodal graph is that we have two groups in one observation. So in this case, if we were to talk about the masses in terms of the context of the problem, we would have a lunch and a dinner rush. So maybe if we were creating like the work schedule for the Safeway, we wouldn't want most people to work at 3 p.m. We would want somebody to work a lunch shift and a dinner shift. All right. Now, for the next one, we're going to be talking about outliers. So this guy right here is an outlier. Now, for something to be an outlier, it's not enough for it to be small, so these would not be outliers. For something to be an outlier, it not only needs to have a small amount of observations, it needs to be far away from our other observations. So what these are the playtime of puppies and the owner, and let's think about some possible causes of this. So let's see. They only played with the puppy between 3 to 6 minutes. So they could have gotten tired. Somebody could have gotten injured. Okay. What else could have happened? It could have been the breed of the dog. It could have been the person was too young or too old or got distracted, right? There's a lot of interesting things that could have happened in this playtime between puppy and owner. Now, here's something I notice when I look at this outlier, is that the playtime was between 3 to 6 minutes, right? Well, most of our other data is between 30 to 60 minutes. So another possible cause of this outlier could be a typo, or it could have been misentered data. So whenever we have an outlier, what we need to be careful about is following these 4 rules. First one is report the values of your findings, so all of them. The second one is realize it could be a source of error, but also it could be something interesting. So what if the puppy did get tired? Like, we want to explore that. Like, what's wrong with this puppy? Is it the breed? Is it sick? Does it just not like the certain kind of play? Like, it's something that leads you to another question. The big thing is that we don't ever, ever, ever want to throw it away without noting it first. So you don't ever want to edit your data without noting it first. That way it doesn't look like you're cherry picking and doing something unethical.